Welcome to the Rocky Mountain AI Interest Group. The following presentation, entitled When AI Systems Fail, was recorded in October 2025 on CU Boulder's East Campus. Presentations were made by Ken Fricklas, Beth Rudden, and Marisa Ferrara, Boston. Chapter markers are provided below in the description field for you to navigate to each of these presentations.
All right, as Ken gets set up, I'm just going to help kind of level set the evening. We've spent a couple weeks enjoying designing this evening, and we want to tell you what the plan is. We're really in a place where, I want to start with a provocation. We're drowning in AI hype, a lot of us. Every week brings these new models, new capabilities, and new promises. And now this agentic AI systems that can set their own goals, plan autonomously, and adapt in real time. A lot of us are thinking that this is incredible. It sounds efficient. It sounds like the future. But what happens when the autonomous systems fail? So we want to get into that tonight and really understand how can we, what happens when they optimize for the wrong things rather than the things that you're telling it to do. Can that cascade out of control? Yes, it can. And there's ways in which we can think about this. And so we want to talk about, Ken's going to start off when he's ready with defining what an agent is, give you some examples there to kind of set the stage for what Marisa Boston's going to, Marisa Boston, who's going to show us how to monitor AI and think about what does adaptive resilience look like when we build our systems from that institutional and programmatic level. And then we've got Beth Rudden from Bast AI, who's well-renowned in understanding the explainable AI. Can we actually explain these systems? Can we look under the hood? Now, a lot of this is going to be tech-focused. We've asked our speakers to apply this to real-world applications. So I think you're going to really appreciate both the full spectrum of technology, understanding under the hood, but also the applications of why this is so important for us. And we welcome your questions. We're going to be using a web-based application called Slido tonight. And you'll see a QR code in a few minutes for you to be able to access that and enter in your questions, which is a little bit of an experiment. A lot of you have been to RMAIIG meetings, and we've done Q&A with the mic, which we will give that opportunity as well. But we want to try out a new way to capture questions, especially for those that might not want to raise their hand, but enter a question into an application. So be on the lookout for that, and we'll explain that in a little bit. Ken, are you ready?
Sure. Am I using that, not a clip?
You can use this.
I can.
You want to?
That's all right. I'll use this.
Okay.
All right. So we're going to start off, because I'm also the guy who does the book giveaways, with a book giveaway. And because we're having a slightly more technical topic this month, I'm actually giving away a slightly more technical book than usual, which is Building Reliable AI Systems. And we're giving away 5 copies of that. I have 5 coupons to give away, which are awesome stickers that Marisa gave me because I forgot my actual coupons. And they have a great GEP box quote on it. Some models are wrong. All models are wrong, but some are useful, which pretty much describes everything about AI in one sentence. So, okay, so there's 5 copies. It would be helpful if you want a copy of this book to actually know Python. So we're going to do a quick Python quiz, trivia. And anybody who answers the question first gets a copy of the book. So we'll have 5 questions. So if you win one, don't answer again. So the first one, who invented Python? Wow, okay, Guido von Rossum. Come get one of these. All right, the next one's a little bit tougher. Everybody ready? What year was it? 89, who said that? All right, yeah. I did not know that until I was putting this together. Okay. What's the version of Python that runs in a browser? It's a really dumb name. Somebody can probably guess it just because if you know Python, this is the way everything works. Close. Shorten that. It's Brython. Yes. All right. Nobody gets the third one. I'm going to have to give this to somebody random. Okay. What's the output of this code? You don't need the punctuation. Super simple Python question. Who said that? All right, yes. So somebody knows how to use the slice operator. And then the last one's actual trivia. This is like one of those things you will never, ever use in Python, but it's kind of entertaining to know. What is that? What's magic? Who said that? Yes, it's infinity. So, for no good reason, Python has an infinity operator, which is just float INF. So that was our Python intro. Okay, let's go ahead and jump. I want you to know, first of all, because the new version of the Google video generator came out this morning, I thought that since I'm going to be talking about agents and what can go wrong, I should do a video of the RMAIIG logo when something goes wrong. Which I liked. All right. So, thank you, Google, for that one. Let's go ahead and jump into. So, let's talk a little bit about agentic AI. How many people in this room have actually used agentic AI? Wow, okay, it's probably a third to a half. That's pretty good. All right, how many of these people in this room have not used agentic AI, but have at least been to one of the meetings where we talked about agentic AI? Got another 15 or 20. All right, so let's just talk about what agentic AI is, because most of what we're going to be talking about here is agentic AI. So up until now, AI has been basically, you would ask it a question, it would try to figure out what you meant by that question. I'm anthropomorphizing like crazy here, okay? But basically, it interpreted your question in terms of how it related to a bunch of symbols, and it outputted whatever it thought the answer was based on basically a string of text. And anybody who's worked on these can tell you the most complicated part of it was telling it to shut up. How does it know it's done? Okay, so agentic AI is a little bit different. So what agentic AI says is, okay, I'm going to have a bunch of things out there, and what I'm going to do is tell the AI what the end result should be, and I want to go build a plan for how to do that, and then I'm going to go figure out what the goal is, figure out what my plan is for doing that, and run a bunch of steps, and I spelled execution wrong. And then in the third one, it actually can monitor that and adapt. So part of that plan is I'm going to go set up some things, which get to look at what my result is, figure out whether it actually matches my goal, and iterate if you let it. Okay, won't always do that, but that's the simple version. So you got 3 steps: define the goal, plan the steps, and execute them, and then adapt. Okay? So all of a sudden, these things are like available to you. So how many of you have heard of Comet? Okay, most people. Comet became available to the general public this morning. Okay, they sort of drastically increased the size of the beta a few days ago and released it to the world. You can use that barcode over there. That is a barcode which, if you sign up for Perplexity, the paid version after the first month, it gives you a free month of Pro. I get $15, but the $15 is going to go towards the Christmas party that Dan neglected to tell you guys about yet. So we were planning on having some announcement about a Christmas party at some point in the near future. Am I okay to say that, Dan? If not, it's too late. Okay, so I'm going to show you a quick demo of Comet. I'll move this over onto the other screen. I'm going to turn my screen around so I can actually see what I'm doing. So Comet is basically just a browser that looks like any other browser. And that was not what I was planning on doing there. There we go. Okay, I don't want everything on the other screen. What's that? What's that? I've just got to get this back onto my screen, so I didn't make a mess, but I'm not quite sure why I did that. So hold on just a second. That's just my presenter view. Get back on my screen. Thank you. All right. Windows getting a little overexcited here. All right, there we go. So I'll look at the sideways version. No, I wish I did have this thing clipped on. All right, so the cool thing about Perplexity, you can basically tell it what your goal is, and it will go figure out a way to do that. So you notice there's some examples built right into here. Set up a quick pitch workspace, open up Google Slides. You can even have it go research what you want in your pitch deck, go look at your website and create a pitch deck off my website. Okay, that'd be an example of something you could just tell it to do all at once. One thing I did today, I'll just show you right now. So I actually had a futon collapse a couple of days ago. All the bolts broke at once. It's very old futon, but I was really expecting that to happen. And so now I have a bunch of these bolts which are like stuck in the holes on this futon. Okay, TMI, right? But I was just like moving it and bam. So I couldn't figure out how to get these things out. So I was like, well, I'm playing with perplexity. Let's figure this out. So I'm just going to type in a command here, put my thing down for a second. So, I have a bolts that broke in half on my futon. No, actually, none of these are my browser history because I only loaded this version like about half an hour ago. On my futon, find a way to get them out and put what I need in my Amazon cart. So it'll do that.
Not even what
Doesn't care. Okay, so it went and figured it out. It's showing you the pages that it's browsing to in the meantime. Oh, yeah. So it's figuring it out. It's browsing the pages that it needs in order to do that, and it's going to go ahead and stick that in my Amazon cart. By the way, it does play Wordle really slowly. It's actually kind of fun to go bring it to an online game and just tell it to play. So anyway, this is taking longer than it usually does, but okay. So I think I had one already in there because I tried this earlier. So it's going to go there. I can now, where's my mouse? Go over to Amazon and get a look. It'll show you those if you want to. Okay, and you can do sort of the dual mode. And if you go look in my Amazon cart, I want to get rid of the assistant here. How do I get rid of the assistant? Yeah, just open that in a separate tab. And when I go in here, it'll actually find that and stick it in where I need it. So point is, you no longer even have to go through the thought processes of how do I go about doing these kinds of, this is not a terribly complex example, but one of the other things when I was experimenting was just find me a good hotel and the cheapest possible fare to Reykjavik in January and tell me what week that would be and take me to the website that would get me that. So these kind of things actually work just right off the bat. They sound fairly simple, but as we'll see, these simple kind of things can be problematic. So, a whole bunch of things happened this week in the world of agents. The first thing that happened was Claude came out with their version Sonnet 4.5, which has memory. Okay, so it's now caught up with the rest of the world as far as what that's concerned. It's actually a big advantage if you're using Claude code because it'll actually memorize all of the things that you told it before and what you're interested in doing and the way that you like to do things, and it will reuse those as you write code going forward. Okay, so it will learn not only based on what you told it to do, but based on its past successes and failures. So if you said that's not what I meant, or you went and changed the way that it did something, it will actually redo it in the way that you wanted or do it in the first place. Okay, sounds great. Because you've told it what to do, likely based on some simplistic, sorry, I'm trying to scroll here and I don't have my mouse on the right page. Some simplistic assumptions about what success means. You can wind up with things that were slightly unexpected. Now, one thing that just happened in that example that I showed you was it stuck 5 things in my cart on Amazon. Multi-screen thing was screwing me up, so I couldn't really show you that. But it was like an example of the fact that I asked it to do something relatively simple and find the thing that I needed to buy. And think if I just told it to go ahead and buy that, right? I suddenly wound up with 5 of them, or 5 different things that all related to the task, which probably isn't what I meant. So this is where things like human in the loop become important. And this is where it turns out that overly simplistic goals become a problem. So you've probably heard of the paperclip problem. By the way, simple version of what an agent does, how memory works. You basically have a context window that goes into a graph of how all the knowledge works, which goes into ontology, which tells how the knowledge relates to each other. And then it basically updates things until it now changes the actual working environment that it's working in. Is that close? Close enough for this crowd. All right, so you've probably heard of the paperclip problem. If you haven't, look it up, but we're going to show a slightly less obvious example. You tell your AI-enabled smart thermostat to save energy and save money. Something that makes sense to you, right? And you give it access to your other appliances and the rest of the stuff in your house so that it can actually make that happen. So the first thing it does is it says, boy, that refrigerator is using up a lot of energy. I'm going to turn off the refrigerator or turn the temperature way up. And then it's like, oh, I've got food in there, and it's probably not good to let the food go to waste. I'm trying to save money, so I'm going to go sell everything in the refrigerator for you. And then you get like slightly unexpected results when you come back. Let's look at a slightly more complicated example. So here's an example where things really go badly. And this actually came out of a simulation. And so you're basically trying to make a commute system more efficient by, and this came out of simulation for city-based planning, okay? And what we wanted to do is actually adjust bus plans, and this relates to everything related to buses, as you'll see, in order to save money for the city. So it starts making some decisions. The first decision that it makes is that a particular bus route has low ridership during off-peak hours. So it changes that bus to go into a more busy residential area to overall improve the amount of people who are interested. Rider satisfaction slightly improves and the costs slightly decrease, but it keeps doing that. Then it introduces dynamic pricing. So it creates peak and off-peak fares, which shift demand and creates more demand during some of the lower times, less demand during some of the upper times. And it also says, you know what, there's some of these routes that aren't going very often, so I'm going to reduce the amount of maintenance on there, as it put it, deferred aesthetics. And then it prioritizes the faster routes. Sounds good so far, right? But what winds up happening is that it would degrade the service in areas where people were heavily dependent on the buses. Not because there were a lot of riders, but because people were in low-income areas and they have to travel a long distance to work. So the residents in those areas would find it more difficult to get to work and school, plus it was now more expensive at the times that you want to get to work, which is problematic. Then those routes, because they didn't have a lot of people on them, wound up not being maintained very well, and so those buses all wound up being in terrible shape and breaking down and getting dirty, and eventually the public gets really upset about the whole thing. So what's interesting about this, there was no single bad decision. It made good decisions, it iterated on them, and wound up with bad results, okay? It's a real problem with agentic systems. It had a very narrow focus on KPIs. We told it what to look for, increase the overall satisfaction ratings without worrying about some of the satisfactions going down too low, right? We didn't give it global context. It didn't really understand anything about disparities of wealth or anything like that and how people use it. And it was really hard to tell what was going wrong inside of these systems until they went radically wrong. Are you with me? So it all looked good until the last minute. So that is my intro. We're going to jump right into a couple of sessions on, gee, what can we do about it? We're actually going to look at both technical and social solutions, not just simple platitudes, on what you can do to maybe not let the worst stuff happen. All right, thanks.
All right, I'm going to introduce our next speaker. Thank you, Ken. All right, so we've got Marisa Boston, who works on the front lines of the problems that Ken just described. She works with organizations where AI failure isn't just inconvenient, it's catastrophic. Financial auditing firms trying to detect fraud. Healthcare organizations making clinical decisions. These are environments where, as Ken showed us, autonomous systems can drift toward harmful outcomes one decision at a time. So her insights is that detecting failures isn't the hard part anymore. The hard part is what comes next. Autonomous repair in production, without waiting for humans to diagnose and patch every problem. So I'm excited about this audience here to really see what she can show you. Marisa has developed what she calls self-healing AI systems, not science fiction, not comedy. She's able to do it now with major firms and in production. She'll walk us through a concrete example from fraud detection, financial fraud detection, showing how even when AI correctly identifies patterns, outdated knowledge bases create systemic failures. Then she'll demonstrate how her approach automatically detects problems, generates repairs, tests them, and ships improvements, all without human intervention. Please give your hand of applause. That's an opening of the poll. Okay. So this is the opening of the, is it the Q&A? Okay. So the general Q&A, and then we're also going to give you the opportunity to answer a couple of questions as well, which we're going to do after you introduce yourself. So if everybody could open up their phones, and this gives you the opportunity to enter in questions throughout the time that the speakers are speaking, and we're going to be able to see it on the admin level. You can also see the questions that are submitted, and you can upvote on them. So we're trying this as an experiment, and we'd love to have you see if this works for you and works for us. So we'll put this up again, but give you a moment now to just grab the QR code. And this is not an app to download, it's just a website that you would visit.
Now? Yeah. All right.
Perfect.
Okay, so I am going to be talking about self-healing AI systems. I did not come up with this. There are people talking about this, but we are building them. But really, in the end, what I'm talking about is reliability and reliability in complex systems. And the fact is that we are interacting with complex systems all the time. And we have come to expect that those complex systems are reliable. But they doesn't mean that when we built them, that they were reliable from the get-go. In the end, with most complex systems, including agents, we expect failures. And the goal is not to pretend those failures aren't there, but to be able to monitor, detect them, triage them, repair them. And that is where self-healing for these agents becomes so important. So that's what I'm going to be talking about today. And that's the kind of work I do. I think the questions here are about what you do. So just curious about where everyone is. This should be the same code. Is it working? All right.
Click on the polls tab.
Once you're on the website, you can click on the polls tab and answer this question so we can get a sense of who's in the room.
All right, so this is good. Actually, there's a lot of builders and a lot more builders than we usually see. I'm gonna let this keep going. You can keep putting it in and we'll see where it ends at the end. I have another question. For those of you who are in an organization or have your own organization, just curious, where are you in terms of generative AI? And that includes even, I know that a lot of students, there might be students here, right? But how are you guys using it? Where is it? In production. That's so exciting. Okay. So this is actually very different from most of the companies that I work with. I mostly work in highly regulated industries, Fortune 500, and a lot of them are piloting. They have it in production, but in that like weird version of production that is really good for marketing, but not really actually useful if you're trying to do things. So this is actually really interesting to see. So overall, I think one of the themes of this talk is just to ensure that, yes, these agents end up becoming complex systems. And they're not just complex systems, they're complex systems that interact with other complex systems, which is the human organization that they are operating in. And on top of it, they are operating to solve another complex system. So for example, if we take one of my clients, they operate in financial markets. The financial market is something we created that is a complex system, okay? And in order to get around the complexity of that system, and even knowing that there are serious failures that come about from that system, right, we have all sorts of things that we've invented, like some of the work my clients do. Like there are auditors out there who go about trying to test whether people are lying about what they have in their financial statements so that we can keep investing in companies, okay? And so financial markets, super complex system. It's built on trust, and that trust is there because we have figured out processes and operations that allow us to do it. Okay, so I do think that one of the things, even though like what Ken was showing is like, you know, we can think about these slippery slopes, Yes, super complex, but that is not necessarily, that does not necessarily mean it has to be unsafe. Unsafe is actually a design choice. And when we think about some of these industries, I'm going to show an example from one of my clients. This is simulated, but it is very similar to something that actually happened. So we were talking about financial markets, another complex system. We were talking about people who have to audit the books of these very complex companies so that we know that we can invest in them, right? So the people who do this, they're auditors. And they have a variety of frameworks and standards in order to do their work well. And they do it terribly. I don't know if you guys know the state of audit, but usually audit failures are anywhere from 25 to 65%. We still all rely on the system, but the fact is that this is a really, really hard problem for humans to do. These companies that do it are the best in the business at doing it, but it's still really hard. And this is like an example of actually one of the agents that has been created. That's a self-planning agent. And the goal of this agent is actually to go into all of these standards and figure out what they have to do in order to audit a very specific, weird little thing that people care about transactions, right? So they have this agent working, right? And this is the output, and this is the underlying document that it's drawing from. All right. They actually do have humans in the loop to review this kind of thing and be like, okay, this is what the agent wants to do. Super exciting, by the way, for these companies because they don't have to like go in and do robotic process automation, right? This is the same training materials that humans use. That's a huge advantage, right? And if we can get these agents who can take the same training materials and turn it into an effective plan and then do the work, that's amazing. That really is amazing. And so we have this output, we sent it through, and the users went through it, and they didn't notice like some little issues here about like, well, was it pulling the right evidence? Was there better evidence? That's the kind of thing that these auditors think about a lot. But my company builds monitors for these systems, and what we found is actually that this doesn't exist. So the system knows that it has to cite evidence for the plan it has to create. And so it did, it just cited evidence it made up for the plan. So this whole document, the whole citation, this like underlying regulated standard was not there. We caught it, but the user that's there didn't even think to check it. Now, you have to think, like, these organizations work like big old pyramids. There's a lot of people, usually offshore, who are doing a lot of the underlying reviews, and then there's higher level people that kind of bring their expertise on top. They are used to checking other people's work. That is what they do, right? But they never even thought that, like, I don't know, even somebody who was offshore would go about, creating a whole regulation to support the plan. Okay, so failures are to be expected, right? We know that they are going to happen, and usually the first thing somebody asks for, the reason why they come to me, is they want to find these failures. Well, if we're going to go out with these systems, we need to be able to find these failures. And I'm like, great, that's fantastic. And usually I go in, and if this isn't built, we build it for them. And it's just basically something that says, okay, we know where your risks are. We know what kinds of things these things are likely to do. We know the work that has to be performed. Let's build monitors to see if it's actually being done correctly, okay? The problem is that it's a first step, but it's not really going to help us, right? I think the thing that we want to focus on is if we are really going to build systems that we can rely on, it's not enough to sit there and go like, well, we can at least detect when it has a failure. We need to be able to know how to fix it. And that's what we're going to be talking about here. Why does it matter that we want to fix it? So there are, I get like an article a day about something like this because people know we're deploying into enterprise and they're like, are people actually doing this? And they show this funnel that shows like, all these Fortune 500s have tons of these agents in dev, but they're not actually getting out. And I look at this and I'm like, this is really no different, right? So most of the companies I've worked for, innovation wings have 90% failure rates. 82% is actually pretty good, right? So I actually look at this and I'm not thinking that this is really that bad of a thing. What I'm thinking here is that we have a problem over here. Everybody can see the potential benefits. We don't know what those failures are. We don't know what the cost of the failures are. We don't even know how to improve those failures. That is the part of this little funnel that we have to focus on if we're really gonna get that working, okay? So my goal is to broaden that part. There's a whole bunch of people working on this other part, but I'm working on that very little part. Okay, so what we went through so far was complex systems, financial markets, space missions. All of those things are things that we have done even though we knew that we were gonna fail, right? And the whole point was, it wasn't that we knew we didn't want to do it because we were gonna fail. It's that we wanted to put things in place so that even when we failed, we knew what to do about it and we could start incrementally getting towards a more reliable system, okay? And the funny thing is that all of those things that I told you about, which are years and years old, actually operate off of the same exact loop. It's kind of a boring loop. This is called reliability engineering. Does anybody know? Are there any reliability engineers here? Oh my gosh, oh, how fun. I've never gotten that before. So this is not that different, right, from what we know how to do already, okay? We monitor, we triage, we investigate, we repair, we verify. And in most of these systems, the problem is that this takes years and years and years and years. So in the financial markets, for example, when we have auditors and they catch a failure, it can take years before they even know whether that failure was really a failure or not, right? And so most of the time with these systems, we have a lot of time between finding the failure and repairing it and then measuring that improvement. But with agents, we don't necessarily have that because the agents are emitting a ton of telemetry that we can use. And we can also use our own agents to go in and look at that telemetry and measure things and help us along the way so we don't have, like, I don't know, a bunch of like people sitting in your nuclear reactors like watching things, right? We don't have to do that even, right, for a few years. And then on top of it, because these agents have the potential to self-heal, we can actually start seeing this flywheel go a lot faster, right? So this is exciting. Same exact loop we've always talked about, but now we have the potential to get it going a lot faster and maybe start getting complex systems that help other complex systems, which are these human organizations, right, actually figure out these other complex systems we built, like financial markets. Oh, the other thing I wanted to mention here, a lot of times I get asked about like hallucinations and accuracy and all of those things. We actually don't, we use those types of signals, but really what we're after are these types of metrics. These are the things that we're looking for in complex systems in order to improve them. So I know all of the benchmarks that are out there. We don't really do that. We do this. This is what we want to do, and we actually measure this on the entire system, right? Humans, machines, agents, offshore personnel, partners, all of them. They're all in it. Okay, so that's the loop. I'm gonna dig into the loop a little bit. This is gonna be the most technical part of the talk, and then we're gonna like kind of come out again, okay? Because I know there's a few people here that are more technical and are actually builders, and the question is like, great, you do monitoring, super boring, I don't wanna do it. I know, I get it. Well, we don't really do it, right? There's actually a ton of advantages nowadays for us to do this. So the first advantage we have is all of the telemetry. So because of OTel, Open Telemetry, these agents actually, we can track almost everything they do. Most of the agentic systems already have these standards in place. No matter what client I go into, whatever they're working on, we can pull the information that we need off of it, okay? The other thing, though, is that it's not just the agents, it's the humans. That's usually our biggest trick, is how do we track what the humans are doing? So that usually requires some organizational sophistication. we like working with like consulting organizations or other types of services orgs because they're usually tracking this kind of thing, so it makes our lives easier. But even in pharma, we have the ability to track some aspects of this. Then we use automatic evaluators, no human labeling. I swear I would never employ another human labeler again. I used to do it. It is terrible. We do this all with rules, statistics, LLM judges. We do multiple versions. We, of course, use different judges than the agents that the other teams are deploying, and we have them work with each other, right, in order to really figure things out. The critical thing is that none of these things is like one metric that we are tracking. In fact, we take all of these different things and we pull them up into various types of monitors. They usually inform 3 areas: quality, suitability, and efficiency. We find that those are really useful for us to track and to help us with the rest of the work that we're doing. And like, for example, when we were talking about the made-up reference and the made-up regulation, that was found by one of our monitors. We call it reference traceability. Terrible name, but it's essentially an evaluator we have that we go in and we just check to see if something exists that was cited. Super easy to do. We put it into our suitability monitors along with other things like user frustration and very typical metrics there. So that's how we monitor things. This is usually the first thing we go in and do for companies. They're trying to get a system out. We're like, well, how do you know it's going to work? And they're like, and so we build this. And this is how we determine that the system is working as it should, and we can catch potential failures. Okay, but it's not enough. And we can't get paid on just that because nobody wants to look at those monitors, right? It's just like the people sitting near the nuclear reactor who have to like watch those little glyphs go along, right? Like nobody wants to do that. And so now we start using agents again. And honestly, they don't even have to be that smart. We can use deterministic, just straight software, right? To be able to do the rest of the loop and get the humans where they need to go. So instead of putting the humans at the monitors, our goal is to keep putting the humans further and further down so that they're at decision-making areas, and we give them the information they need for it. So we go from monitors, we triage automatically from those monitors. Is it something, a failure? What kind of a failure is it? Can we cluster it? That kind of thing. Then we apply a risk calculation. I don't know how many of you know about the risk cube, but this is really critical for our companies, right? Like, they don't know what a failure is going to cost. And so, for example, if they have an agent that like if it makes a mistake, it's like super critical. Like what we would say is, well, we can tell you what the probability of that agent failing is because we're tracking it. But the other question is what's the exposure, meaning how often is it running? Is it running in limited deployment with like a few people and you could test it out? Or are you running it millions of times a day, in which case your exposure puts it at a very high risk item? That's really critical before we can even start triaging things. You don't want people to even start thinking about whether the failure classes are important until they really understand the risk. And it's very hard to get the people who would be monitoring to understand the risk. So we tried to do that part too. And then finally, we're in regulated industries. In order for humans to review it, they have to look at these failures, right? They'd have to go in and actually look at like the patient documents, the clinical trial records, the financial statements of banks, right? Not allowed, like completely not allowed. It's just not gonna happen. There's various processes, it takes 12 weeks, and you're just not, there you've hit the limit and we can't get that flywheel going anymore. So what we do is we add simulations. And so what I have examples of here is, I don't know if you guys have seen the work on how easy it is to create fake receipts for expense reports. Does anybody know about this? Yeah, my financial clients do not love this example, but yes, it's very easy to do that. But we can create simulations. What we do is we take the failure signatures, we create simulated data of those failure signatures, and then the humans can review them, and they're also useful for testing, all right? So all of this that I've just shown, right, it's agents that help us monitor the agents that are helping the humans, okay? Now the fun part. This is actually the easy part now. Like this is simple. Once you've gotten all this information and you've gotten the humans to triage it, repair packets are like, I mean, this is not the most interesting part of this. That's why we talk about self-healing. The critical things was everything else we got up to this point. Really, it's just a hypothesis of what happened, right? The adaptation that's needed. By the way, agents help us create all of these things as well. What's really critical are the tests, right? Like, how do we know if the repair worked? And the data, that's where the synthetic data comes in so that you can actually test whether the repair worked. And finally, that verification. Like, in other words, we really shouldn't be repairing these systems or doing silly things. Like, we've messed up something else in the process if we're seeing these key measures starting to go the opposite way up to a certain point. But for immature systems, this is where it is. So we have these repair packets. They can be automatically created for clients who want to work with self-healing, which, like, let's put it in like the POC of a POC stage, right? We can start doing this, but really in the end, this actually really helps the whole human process as well. The dev teams finally get a requirement list that they could do something about, which most of the dev teams at these organizations would love anyway. So they really like this stuff. Okay, so that was the technical part of this work. Like, how do we actually do this? This isn't just us talking about things. These are fairly stable ways of doing things from reliability engineering. We're just applying them and using agents to make them work better. And so that the only places that we're doing this, like before it was so expensive that we could only do this for like nuclear reactors or power grids. But now we actually have the ability to do this in more places. So the main point is that we want to move away from dashboards, benchmarks, accuracy metrics, reactive testing. We really want to move towards this. We've known for a long time this is what we need, but we now have the agentic power to get it working. The other thing I want to mention on this graph is we talk about a desired reliability level, and that is like, yeah, go and ask somebody. They don't know. But that's a lot easier than going in and being like, your system's going to fail. What's your failure tolerance, right? It's basically the same question. But we find that this is much more effective framing for our clients because we actually can show that we're moving in the right direction for them to get it out. This also gives us good stage gates to say, okay, at what point can we get past like 100 users, past 1,000 users? Those are really critical things in these regulated industries where they know failures happen. They are very sophisticated about this. They know about this stuff. So this is a really easy sell for them, and showing them that we can get there and it's not like, do you trust it? That's really key. Okay. That is most of what I'm going to talk about, but we're researchers too, and we have a variety of open questions. And we would love to talk to anybody. We talk about these things all the time, so we'd love to open it up to others. I have these open questions in a few different areas: measurement, systems engineering, governance, right? For measurement, same problem everybody has, like these LLM judges are constantly drifting. And like, so our underlying agentic system is drifting and we have to catch that drift, but then the agents we're using to detect that drift are also drifting. So this is just a problem everywhere, right? I'm just calling it out because, you know, the reason why we're using rules and stats is so that we can try to get away from just using agents everywhere because we do know that they are not reliable. Also, we don't use benchmarks. We're really just doing straight real traffic. We're working with clients that have the real traffic and the interesting data that we want. I don't know how that compares to benchmarks that academics and other people really care about. I think that's a good question, though. Like, I think we should think about that. The big one that I think about all the time, anybody who's built a system and is, like, I've been in adaptation for a long time, there's going to be improvement conflicts. How do we resolve them? What is most important? Right now, we use the risk cube triaging, but we could probably automate that. And auto clustering is, we use ML, but it's not great. And then finally, governance. We talked about OTEL, like open telemetry. We pull a lot of data. We want to push data back in, like to talk about this. We're just not quite standards people. So those are some of the things that we think about, that are some of our clients are thinking about, and there's work to be done on. So if you're interested, we'd love to collaborate. I have my office hours here, my email. You can feel free to reach out. Our two companies, and we this is actually also a white paper if you really want to dig into the technical things, the math, all of that. It's all there. So thank you so much for the time. So are we doing questions? I think we do questions at the end? Yeah, at the end. Perfect. All right, there you go. And I'm handing it off to Beth Rudden.
Yes.
And you're using that.
I'm going to use this.
Okay, perfect.
I love this room. Testing, testing. You guys here? I have no pockets. Good evening. Good evening. Thank you, everyone, for being here. I was looking this up while Marisa was talking. Test, retest reliability and what failure looks like is actually no joke. If you guys have heard of the Boeing MAX and 346 people that were killed, that was because they didn't tell the pilots that they changed the software and what failure looked like. And so even if you have a 99, you can't hear me still? How about now? Do I really have to lower my voice? Test, retest reliability for women speaking to mics? No, I'm just kidding. Boeing MAX, 346 people were killed because they passed all of their tests, but they didn't actually test pilot confusion. And so it's super important to understand what happens when things fail. And you have to know what that looks like, and that has to have that same test, retest reliability to understand what it looks like when a system that is accurate 99.9% of the time, over 1 million people, that's 1,000 errors. In Jeffrey Moore's Crossing the Chasm, who's heard of this book? Anyone? All right, great. Technology leaps from early adopters to mainstream markets. But AI is different. It's crossing minds, it's cognitive, it's reshaping our society. Tonight, let's shift our gaze from those building massive models to those using AI safety and programmatically exploring what it means to be human in the age that machines can predict. My journey to becoming CEO of Bast AI, an explainable AI company, was not linear. I started out as an archaeologist in Tuscany, digging up Etruscan artifacts and struggling to correlate them objectively to what the hell they were. This taught me to scrutinize my own bias. Most archaeologists really explain what they think about the world. History is not written by the victors, it's written by the archaeologists. From there, I pivoted to programming, information systems architecture, data science, and I was a global executive at IBM. And this is where I learned that technology isn't just code, it's a mirror of human experience. This is a picture of the Danube River on the morning that I arrived in Budapest. They had lost my luggage, and I had a keynote in front of 4,000 people the next morning. It was really interesting because what I would do as a technical executive is I would go into these technical leadership exchanges, and I would be traveling around. We were operating in 175 countries with 350,000 humans. And I would present regional skills of what was going on in that region. And the people in Central and Eastern Europe, I had a team in Belarus, Kiev, Brno, dual PhDs, mathematicians, physicists, statisticians, brilliant, brilliant people. And I would put a word cloud of all of the PhDs, all the skills, all of the technical talent in that region for every region that I would travel to. The next morning, I would sit down for breakfast, and invariably somebody would come and sit next to me or exchange bread and eat together. And this one gentleman, a Hungarian gentleman, looks at me and he says, "Beth, I need to tell you something. I was taught that everybody from Romania was stupid. One generation off of communism, most of us were teenagers when the Berlin Wall fell. Being taught that Romanians, an entire race of people, were not as intelligent was something that he began to question when he saw the word cloud, and he had never thought to question it before. And he said, I sat down with some Romanian people and I talked to them and they're not stupid. And he was mortified. And it's something where when we realize that people are understanding what they are taught, and when you have communism and you have the entire control of teaching and the lack of free speech, this is something that I think that we're only starting to learn, potentially too late. But Eastern Europe, there is an inoculation because they understand that what they were taught, even in their generation, is not even close to what they have experienced themselves. We're going to do a Slido poll. What is a word or a phrase that answers the question, what is data? This is a word cloud. If you guys poke on it and copy and paste it, or say it multiple times, or type it multiple times, it gets bigger. Information, structured information, the new oil, insights, everything. Description, less than a piece of information. Character from Star Trek, evidence. History, facts about the world, raw. Bias, green, small bits, opinion, observation, Lego pieces, knowledge pool, factoids. That was my favorite. Thank you, guys. This is awesome. I've surveyed hundreds of people, if not thousands of people, potentially tens of thousands of people. And what makes me smile every time is the difference in all of our responses. We all know that data is the new oil, the new soil, the driving force of all AI models, but we have no common definition of what it is. So being a good anthropologist, I declared, data is an artifact of human experience. Data isn't abstract. We create it, or we build the system that creates it, embedding our signals, biases, cultural contexts, our learning into every single piece of data. It reflects our perspectives, shaped by who taught us, how effectively we were taught, and how we know what to be true. In archaeology, I learned that artifacts carry the biases of their creators. The same holds true for the data scraped from the internet, now encoding our global scale human biases. Anybody seen this chart before? This is the cognitive bias codices. It is a codex or a map of the 180 human biases that every single one of us carry, and counting. To give you a really quick story, I had data scientists and designers take the Titanic data set, which is the data set that most data scientists use to be able to predict who survived and who died, and what features or predictors were in that data set that they could predict. And they found that the predictive element of getting onto a lifeboat was class of service, not whether you were a woman or a child. If you were a woman or a child in steerage, you had less of a chance on getting a lifeboat than a man in first class. That is a social bias that was common at the time that we can read in the data. Another bias that I wanted to tell you guys about is willful blindness, also called magical thinking. And when a radiologist scientist started doing testing and realized that when you X-ray pregnant women, you cause cancer in the baby. It took 25 years to stop X-raying pregnant women after she had proved it, and a man had also had the retest reliability to be able to make sure that her results were true. Good example of willful blindness. My favorite quote from Arthur C. Clarke: any sufficiently advanced technology is indistinguishable from. Yet, MIT reports that 95% of enterprise AI pilots fail. Let's talk about the 5% that succeed, right? You're not trying to apply a magical tool of general AI to your domain-specific problem in your enterprise. You cannot use your general encyclopedia to solve your accounting problem. Most successful AI deployments aren't the ones that feel the most magical, because magic just works. Do you guys remember Bewitched? Twinkle, twinkle, twinkle? Like, you just wave the wand, it just works. AI is not magic. It's engineering, it's a lot of testing, it's a lot of understanding exactly what you need to do to make it work. So any sufficiently advanced technology is indistinguishable from magic until you show the human how the technology works. In your experience, making important decisions, what matters most? How many of you guys have heard model context protocols day in, day out? Well done. This is really just to set you up. Who's seen this graph? All right, I'm going to tear it to pieces, just full stop. It's from a study that exposes AI's cultural blindness and distinctly narrow point of view. So all of the foundation models, cultural aspects, how people solve problems, how people approach strangers, how people may understand what diplomacy is, how people understand education. Cultural, your memes, your tropes, your mores, your understanding of your cultural values. They surveyed 150,000 people, 153,000 people in 107 countries, and they came out with this indices, like this XY axis. And then what they did is they tested all of the foundation models. Do you see the little blue amoeba up there? That is the representation of the cultural representation of all of the foundational models. But here's what the researchers missed. Look at how they drew the axes. They labeled the vertical axis traditional versus secular, immediately implying that secular is somehow up or superior to traditional. The horizontal axis shows survival versus self-expression, suggesting that self-expression represents advancement beyond mere survival. These aren't neutral measurements or plots. They're value judgments. And the authors unconsciously created a map where Western values literally occupy the higher and more advanced quadrant of this chart. So I redrew it just to give this example. Instead of sorting cultures on imaginary lines of progress, let's see the truth. The foundational LLMs draw from a single cultural ecosystem, this lone daisy. While the world is this vibrant, multifaceted garden, each flower has its own beauty, its own way of thinking, its own solutions, no hierarchy needed. In just 2 years, AI has created 90 zettabytes, or 51% of all of the world's digital information. It's like comparing a beach ball to the sun. Why this matters? When one source becomes this massive, it starts crowding out everything else. The beach ball represents all of human history that is not digitized. We're at risk of turning our beautiful, diverse garden of human thought into a field with just one type of flower. The good news, there is a vastly different way to build AI systems. In 2023, 1 year after I opened my business, Vast AI, after spending almost a decade really talking to people and trying to educate a market on what responsible, explainable, ethical artificial intelligence could be, I decided to build it because I was sick of talking about it. And in this podcast, a gentleman in Colorado found me, and he runs SimWorks, which is an EMT paramedic training system. And he's like, Beth, have you ever heard of medevac? And I'm like, absolutely. Husband flew that sexy helicopter, 3 deployments, 23 years in the military. I had access to medics, to pilots, to crew chiefs. And the biggest thing that they needed me to do is see if I could help them surface next steps in their protocols, their procedures. And the thing about emergency personnel is they're trained verbatim because you don't make shit up in an emergency. So we created a system in 2023 that would produce the exact picture from their protocol, and it was different. Army people give fentanyl, Marine people give morphine. And what we did is we showed that you can have the test, retest reliability with full lineage and provenance by actually selecting the correct systems to be able to use the data in a way to surface whatever they needed to surface with the process flow chart, everything. So we created a trust layer. And what we do in VAST is we start with the AI infrastructure. We use parallel processing and code architecture that actually operates off of Kubernetes clusters on CPUs. We are 70% less compute and an 8-week deployment versus 12 to 18 months. I want to show you guys like a little bit of a demo here. So what we're doing is this is a neurospine rehabilitation center. And we wanted to demo something that we can ask the same question over and over again, but in different languages, to be able to show different outputs using the same exact context. So there it is in Spanish, same picture of the page from the outpatient procedure. The CEO said, she's like, Beth, we have to stop handing paraplegics a binder of paper. And I'm like, I got you. We can do this. You can ask the AI system to give you any version of what is a TBI or a traumatic brain injury, and it will give you in the language or in your level of education, or if you need to explain it to your 5-year-old. We use ontologies or maps of the data systems that we ingest. So this high quality primary source data, we ingest that into a fully versioned system of record, and then we use an ontology to be able to map it so that we have the test, retest reliability, and when it fails, we know what it fails to, and we know what it looks like. What we're doing now in healthcare, 70% of patients don't follow discharge instructions because they don't understand them. Who's read a prescription front to back when you go to Walgreens and get your prescription? Anybody? Yes, awesome. Wouldn't you like to be able to interact with that? We know that patients are Googling, hell, providers are Googling and ChatGPTing medical advice. We know that generic chatbots give hallucinated response. Think that Encyclopedia Britannica solving your accounting problem. Much worse if you're trying to solve a medical problem. Stacks of confusing PDFs. Patients are afraid to ask stupid questions. We offer full source attribution, full lineage and provenance, stage-appropriate data delivery, personalized gateways, hospital-branded interface. Every single CEO, actually, I'll do it this way. No CEO has told me, no, Beth, we want them to use ChatGPT. We want them to use that source. Patient journey today, massive, crazy, hard, difficult. You get a call as a mom in Seattle that your kid's being transported to Inglewood, Colorado to a neurospine rehabilitation center. What do? We took that patient journey and we looked for the friction points, and we give verified instructions and follow-ups to keep things moving along so that all of these transitional boundaries are a little bit less frictionful. We created an app, and I'll show you a little bit of it. Giving people the option to choose, do they want detailed explanations? Would they like full explanations? Would they like to see all of the information in English, or do they speak another language? We allow people to hyper-personalize the promise of AI. We give them the ability to interact with a system that they can ask questions in the privacy of themselves. All of this data retains to the person. All data and insights belong to their creator. We can allow them to voice command, because people with traumatic brain injuries should not be looking at screens. We can give lists of questions for their doctor that they're about to see. They can edit those questions, and then we follow them along in their patient journey. If a doctor comes in their 15 minutes, they can take a transcript. Then they can interact with that transcript. They can say, what is going to be able to be shown to my doctor? Do you want this summary shown to your doctor? The AI says, what would you like to be shown? We can summarize it. We can leave the personal information out. The person says, okay, I think that that's fine, but can I change my mind later? Giving people dignity, giving people privacy, giving a way that you can actually understand where your data is going and where it's being stored. We're giving people a way to really help them prepare the patient for the doctor, for the provider, where we can offer people the ability to say, how about start with what you want to get back to? This example is, I'm a teacher, and I couldn't remember that word for calculator, so I kept telling my daughter math thing. And the AI suggests, well, tell the doctor that you want to get back to teaching and that you're having trouble remembering the right word. One of the hardest things about this particular situation is getting home and having a checklist. How do you prepare the wheelchair ramp? How do you prepare the human factors for what you need to eat? How do you not fall when you have to take a shower and your caregiver is in the process of that? How do you get your caregiver to put their own oxygen mask on first? How do you access videos to understand all of this? All of this primary source type of data is what we make accessible, and what BAS does is we put a layer in between your primary source data and any AI system so that you can be safe in using all of the AI that is out there and using it specifically to reduce the friction of communication between the provider, the caregiver, and the patient. In conclusion, we began tonight about talking about crossing the chasm. That leap from early adopters to mainstream pilots. But AI's real chasm isn't about market adoption. It's about crossing from magical thinking to practical implementation. AI is not magic. Humans create the data that build these systems. Explainable AI is the way to get it all. And you don't need big data and big compute to build trusted AI. Thank you. Then we can do this way if you want.
Oh, okay, great. Let's get that chair up here and let's get everybody up here. Thank you so much, Beth. That was incredible. Yeah, we're going to sit here.
Okay.
All right. So we're going to do a little fireside chat style. We're going to take some of the questions that were in Slido, and then we're going to bring the mic around and kind of start from what some of the questions are already. Beth, since we ended with you, I'm actually going to start with a question that came right at the end of your talk, just so we can get right to that, and then we'll switch back around. Have you considered having BAS be a resource for families with a parent with dementia or Alzheimer's?
Absolutely.
Is it on?
Thank you. Thank you very much. Absolutely. I think that that's an incredible use case. I think that elder care is becoming very, very much on the top of at least people in my generation's head. And I think we don't know enough about Alzheimer's and we don't know enough about dementia. But we do know that the biggest and the most difficult thing that we have to encounter is stress. So if there's any way that we can reduce the stress of the caregiver, reduce the stress of the patient, keep everybody in a way that they can not catastrophize or not let their scaries spin them into different places, I think that would be an incredible use.
Great. And then another one that came up, are many companies deploying AI agents in high-risk systems? Are these agents making important decisions, or do they provide support and suggestions?
Since I'm a member of NATO, I have yes, of course, people people are doing all kinds of things. I think that the genie is out of the box, or Pandora is out of the box, where everybody is trying to utilize AI in any situation that they possibly can, especially if it means large government contracts, being able to build more data centers, being able to enhance the cycle of what's happening today. And I don't know that, one of the ones that I do remember when I was doing, I have books, if anybody wants a signed copy. I brought a couple, but in my book, I give a lot of examples, and this is one in a welfare example where it was a Midas AI system that doled out or decided how much money to give, and it was known to be 14% accurate. So a lot of people did not get enough money, and many people died. I would say that that's a good example of a high-risk situation.
Go for it.
So I have a slightly, I think you're right. I think anywhere that you see people not having enough resources, you're going to see them using these things. In the industries I work in, they understand the gravity of the situation, and they're usually building things with many years of, pharma, for example. It takes 15 years to get something out. These are not people who are in the business of, race to the bottom. They understand the importance of quality and control. And my experience is thoughtful deployment. The hard thing that they are dealing with is the fact that all of their workers have their own version of ChatGPT that they're using, right? So that's really going to be the critical thing that they're seeing. But I actually, I think especially among the Fortune 500, they've been innovating, they've been dealing with technology, they have digitally transformed, they have done these things, and they've had the resources to do it. And so I see sophistication, but I also see a real understanding of the cost of how to do this well. And so in my experience, lack of regulation is not changing the fact that they are definitely building these things thoughtfully. They don't care that there's no regulation right now. They know they have 15 years and that regulation can come back anytime. And frankly, they work in an industry that has largely tried to regulate itself, right? A lot of times these industries, yes, there are government and public regulators, but they want to do the right thing or else they go out of business. So I know that I know that there are those stories, but in my experience, especially like I see more sophistication in how they're trying to deploy it. What they do have right now is the fact it's just like with Excel, right? Or like when Excel first came out, it was coming into these organizations from people bringing it on their own PCs. They did not actually buy Excel. So that's what's happening right now.
Yeah, let me talk a little bit to, trying to remember what the word, basically crowd effects. So the one issue that we run into when you look at like market panics and things like that is, a whole lot of decision-making machines in 2008 and previously people in 1929 go and get a new opinion about something. They all change their behavior very rapidly, and the system that they exist inside doesn't have time to adapt. So where these high-risk systems can fail is that they're being tested in a way that basically looks like in the signature of what everything looks like right now and among observed expected eventualities. And where things don't tend to get tested very well is on the edges. So, since Marisa's working a lot in pharma, one of the problems that we've got in pharma has been that things get tested in isolation. They get out into the world, and then all of a sudden they exist in something where, oh, hey, this person's taking a lot of vitamin D, and we didn't test that, and this thing reacts with vitamin D. We're going to see the same kind of things in the agentic world. We're going to see behaviors change as the result of a whole lot of agentic systems being put into place at the same time, and we don't know what those outcomes are going to look like. So a lot of what some of these systems, especially when you start talking about things like, nuclear power and water-based systems and things like that, is we have to put brakes in place. Basically the same things we did with the markets, where we basically said, if the markets start dropping really fast, there's all stuff that got implemented after 2008, the market basically shuts down for a while. Sometime the longest shutdown I think we've had so far has been about 2 days, but there's been a bunch of them. That was after 9/11. But in general, a lot of this stuff is about saying, hey, we're observing unexpected behavior. Let's just stop performing whatever it is we're doing right now.
So that gets to what's the solution, which is the question that has been upvoted by 6 people. How do you prevent prompt injection attacks and agent looping redirection? I think that's for you, Marisa.
Oh, wait, but before we get to Marisa, I just want to say one really quick thing. So there was an article in Time magazine this week about this, which is not usually where you see these kinds of things. And it was actually about the Comet browser that I just showed, which basically shows that Comet's taking a lot of its instruction based on how it reacts to what it appears on a page. So you can do a whole new version of prompt injection by sticking stuff on a web page, which then gets absorbed by an agentic browser and does something that it wasn't designed to do. So.
This is like even more basic. I mean, people are putting like white text in their resumes so that the HR bots, right? Like this is not, this is not, I don't know. But I think, and again, I think that when it comes to prevention, usually when we find out how to prevent something, it's after years of watching failures and collecting data and, really analyzing it. I don't think we can prevent this yet. The other thing on this is I know that these are the kind of worst case scenarios, right? And I don't know anybody who's gotten a job from an HR bot, right? But in the end, these are the types of things where I think the vast majority is going to be fairly benign. We're going to learn a lot from these fairly benign cases, and then that's how we're going to actually start to understand prevention. But most of the time, you need to fail before you know what the fix is.
I'll say one more thing about that, just a plug for ML Commons. So ML Commons, which I'm one of the leads of, came out with their prompt injection benchmark this morning. It's like the 0.5 version, so it's not quite ready for prime time, but it kind of shows just how much various foundation models can degrade with various types of prompt injection attacks. And the ones with the biggest gap between essentially safe without prompt injection and essentially unsafe with prompt injection are the ones to really watch out for because their behavior is not predictable, right? So this kind of goes back to, is there an AI devil's advocate? And yeah, and this isn't the only case of one of these organizations trying to build one of these things. The idea is to come up with things where we can at least identify things as being essentially risky. And I think the first step in preventing prompt injection attacks especially is identifying where things are vulnerable, right? And then we can start putting safety where it exists.
You should sanitize your inputs. No matter what you are doing, if you are feeding your agent inputs, you should know what you're feeding your agent.
So there was another question that I wanted to address, the cost trade-off of improving process versus the cost of failing. I think that's we talk about that all the time. And I think that you were bringing that up as well. In general, like, you can restrict, and I think that this is kind of what you were getting at, Ken, right? You can restrict a lot of like severe failures by just not putting it out everywhere and making it operate, right? Like, there are a variety of ways in which we can reduce exposure while we are testing these systems, right? It's not like we had, 800,000 passenger jets going around when aviation started, right? So I do think that there is definitely a trade-off, but from my perspective, I don't think that the cost of failure should be so high or something that we should be scared of. I think it's the only way to get better. It really is. These systems are too complex. They have to operate within a complex system, which is our human organization, and we are using them all the time with other sorts of complex systems. So in my experience, I actually think that what our goal is to make the cost of failure, we want to reduce the exposure, and so that we can actually study it, and then we can start to build up some of these things. So that is how we try to operate and how we try to help organizations deploy.
And we can use existing frameworks, existing protocols. Like, I was talking to my husband about people who want to lower the number of hours that pilots need in order to become an aircraft pilot, because then they can get more pilots out there. And he's like, every single one of those rules are written in blood. We've already paid the cost. We can learn from what we know to be true today and study history.
All right, we're going to open it up to, let's get some hands up.
Oh, a quick comment. So a bunch of the questions that were very just what are you talking about kind of questions, those got answered on the Slido.
Yeah,
so if you're
we
looking
did some
for
digital
answers, just
answering.
like what's telemetry, look in there because those answers are
You'll
there.
see those answers, yeah.
Okay, question here in the middle.
Great.
I was very interested in that diagram that showed sort of the cultural bias of AI compared to the whole rest of the world. And I remember from travels in kind of some remote areas how Western culture has this way of killing off some very valuable practices and information and norms and things. Is there any sort of safeguards or guardrails happening that you're aware of that are either going out and sort of incorporating some of that information or somehow at least protecting it until it can be?
So we have these civil servants in every single one of our communities. They're known as librarians. And they have curated the information for that local community. My dream is that we will all have language models for every local community where the librarians are the stewards of information. So you could talk to a language model from the Bronx about the Bronx. You could talk to the language model from Boulder about Boulder. So we have the technology to do exactly that. We are not, I mean, the Maori have a language model that they're using to preserve some of their culture, and they have a very different view of data in that when data is given or exchanged, it's an exchange of some part of a person to another person. which is actually a hell of a lot more accurate the more that we learn about data.
On that tack, there's a project going on right now to build a language model that can negotiate contracts on the part of cultures that don't have money, which is a complicated thing. So, and it's actually one of the interesting aspects of that is they learn that a lot of these cultures have a few members who have gone out to Western countries and become lawyers who have been doing that. And those guys wind up with the Western cultural biases and don't necessarily represent their community as well. So they're looking for basically a way to create translation built right into contracts.
I think this question is probably mostly for Marisa. I know you're working within these complex organizations, and you said a couple times within complex human orgs in doing this. And you mentioned the AI, how you're tracking agent risk in these, right? And the NIST, RMF, and EU AI Act are really focused on material use and safety and life. But then you mentioned humans using ChatGPT on their own. And at some point in these orgs, the line between what's being done by agents, what's being done by humans using AI is going to blur pretty significantly. So I'm wondering to what degree the direction of your company is moving towards the comprehensive, like how does the organization manage human plus agent risk as opposed to standalone agent risk systems?
That's exactly where we're going. So we do not have any architectural requirements on the underlying system. It can be any number of agents built in any number of systems, including biological humans. So we actually do not what we are really looking at is the organization. And we do also do work. We have some papers out on, human-machine interaction, which, a lot of it comes out of the military has been doing this for a long, long time, right? But in organizations, it's actually super interesting. I mean, some of this work has been going on in organizations from like the 50s, the 60s, but we really have an ability right now to really rethink how this is going. I also think the organization is going to change because organizational knowledge, which is so important and which gave them so much advantage, it's now going to become more accessible to smaller groups of people, and similarly, smaller groups of people are going to be able to become fraction. So I think that there are going to be some interesting things happening here, but essentially, our answer to that is we never went into this thinking that we were going to be measuring like just agentic systems. We've always thought about this as complex systems, and actually software has always been a complex system because humans were interacting with it. So, yeah.
Great question. Other questions? Phil, right over there, one question.
Okay, humans are wired to detect threats for survival. Does this propensity for humans to see the negative side of things first over the positive cause a bias that should be considered in this?
Absolutely. If anybody like tries to fill in the gap of what is going to happen, I talk about this all the time with my children who may overhear something and they're eavesdropping. And it's like human nature to be able to fill in that gap with you were talking about me, or, especially if they're teenagers. But I think there's so much that we can learn from actually AI systems that can help us see and be a mirror to what that data is actually reflecting. And how many of you guys have noticed that your iPhone, you can search for things like trees or spirals, or, the search has gotten a lot better, right? Well, imagine searching for misogyny, or through like 3, 5, 10 years of emails, or searching for ways where one person is having power over another person, or ways that one person is offering power to somebody else. So imagine searching for things that you are not even aware of, like a negative propensity bias in your thoughts. And you can see that in the language, in the way that I always do this with like the data scientists. I'm like, why would you choose gradient descent and Taylor expansion if you want to optimize linear systems for complex adaptive systems that have no linearity? Like, why would you think that that's predictive? So it's very interesting because we're just at this brink where AI is the electron microscope for the human condition.
And on top of that, I think that's like a huge advantage of how we build these. So like building off of what we were just talking about, like measuring the whole complex system that's trying to do the work. And frankly, humans aren't always the best at doing these things. We don't just get paid when the AI sucks. Like actually, that's not my goal. That could be a business model, but it's not my business model. And what we try to do is make the whole system better. And so we know that humans have serious issues being able to detect fraud. We've been trying to build tools that help us detect fraud in all sorts of different ways, right? The ability of knowing the bias that humans have, the fact that we can't do 100% of anything, right? That actually gives us an advantage to be able to put these agents in the appropriate places and actually make everything better. So in the end, detecting failures and understanding the human limitations actually gives us a much better way to develop the requirements for building these agentic systems.
I was just going to say, one of my favorites is measure what you treasure. So if you want to incentivize the human being to do whatever it is that you want to incentivize them to do, that becomes your measurement.
Okay, next question off here to the left side.
Great. So that's really interesting. If an AI agent can, I'm not a techie, so hopefully I'm saying the right things. If an AI agent can detect misogyny, and let's say you're a misogynist, and you don't want to be a misogynist anymore, do you put a goal in Perplexity and say, I don't want to be a misogynist anymore? Will it tell you how you need to change?
If you program it to do so. But what I would also kind of like think about there for a second is like data as an artifact. So if I try to introduce like a piece of a journal entry, and I say, this is a journal entry, look, it's like coffee stained, and this is a real journal entry. And, people are like, what? It's just a journal entry. And then I bring you the journal that it's from. And like, you can see how it's sort of like ripped out of that journal. And they're like, oh, okay, well, you probably didn't fake the entire journal. And then I bring you 20 more journals that look identical. And you kind of like get that empirical evidence. And you're like, all right, this is actual evidence. I agree that this is actual evidence. I think that is what we are in the age of transparency, where we can start doing that type of like forensic archaeology and analysis to understand, why the system is, why the system is annotating or classifying or labeling this type of behavior within this cultural context, within this data system as misogyny, for instance. And one of the reasons that I love explainable AI, especially when you're dealing with language models, is you can deliver the right answer that is 60% accurate. We have the unfortunate problem of language. There's a sender and a receiver. So, the fallacy of communication is whether it's even happened. So how we perceive our own reality and how we receive information is incredibly individual.
So, Beth, are the current foundation models considered explainable right now?
No.
So, like I'm using one for scoring a game, and I submit the person's guess and the correct answer, and I say, please score this and tell me how you scored it. And it gives me a score, and then it gives me an explanation of why it scored it. Why is that not explainable?
You're doing the inputs. So you're saying, here's the score, right?
No, I'm saying here's the person's guess, here's the correct answer, and you score it from 1 to 100, and then tell me why you delivered the certain score. So it comes back with the score, and then it says, here's why I gave it that score. Why is that not explainability?
It's lying. So the thing is like we do this, right? Like we check, we give it plans, and we watch it do things, and then we ask it to tell us what it did, and it doesn't, right? Like, so it's very inaccurate usually, and what it knows how to do is deliver an explanation that you'll accept. It's not necessarily truthful.
So that maybe sounds good to you, but isn't accurate.
Ask it the same thing over and over again.
Yeah.
Does it give you the consistent answer?
So actually, what is interesting is there's a lot of work going on in this area. And so the reason why a lot of the models now, when you ask it a question, it shows you what its thinking steps are. So basically what it's doing is it's breaking down into chunks each step of the process, and it's only building the actual answers using these small chunks. And those chunks, it can basically tell you what it thinks it's going to do, give you a little block of text, and then go reanalyze that. And if you look at that in retrospective, you're kind of getting something close to an explanation of how it got to the answer that it did. But if you start at the end and you go ask it what it did, unless it logged all those steps and it's showing you that log, it's doing exactly what Marisa was talking about, which is just coming up with a good answer that fits the question that you asked it, because it doesn't really have anything to base that on. It actually doesn't know anything about how it works. All it's doing is basically explaining to you using language what might add up to the solution you already gave it. And that's why they're such effective liars.
Thank you. 5 minutes left. Any questions? Raise your hand.
Yeah, a couple up there.
We do this. So our LLM judge monitors, right, on a lot of things. Like I said, I don't want to deploy humans, and a lot of things that we need to check. Like, what's a good example? Relevance. I check relevance of something like the system, the agents and the humans create deliverables. And we have to say, is what was written here relevant to the question, for example, right? And relevance is something that we've used in NLP for a long, long time, and it's always been bad. And so but we're hoping, but it's always still something that we measure, right? Like it's still something that we like to know, and it's a good signal. And so we use the signal of relevance. Now the problem is, I don't want to put a bunch of humans to determine if the answer was relevant, and we're looking at like millions of chat sessions at this point, right? So we use LLM judges, and what we end up doing are like LLM juries, right? Where essentially these LLMs like interact, and then there's even tons of economic research where like, and with the synthetic company that I have, we create simulations, and those we take distributions of responses across very specific agents, and we use them. So that's where things are right now. So in most quantitative fields like Likert, if you can do human survey responses, you can actually do agents for this. With Likerts especially, the distributional responses at like 20 agents is usually pretty accurate. So that's what people are doing with this. They're using all sorts of different agents.
And for those who actually build LLMs in this room, one of the more interesting technologies that's being used a lot to do this now is you actually just turn off random parts of the LLM itself, and you just run it against different sections of your LLM and see if you've got consensus. And one of the big advantages of doing some of these things, there's another use for this, which is that one of the biggest problems we've got with large language models is they're 100% confident of everything they do. They have no concept of uncertainty. So if you can actually have this thing run across multiple agents and then compile them, you can get a statistical correlation between whether or not this answer is likely to be accurate. So you can basically say anything below 70% accurate ought to be thrown away, make decisions like that.
Like, to be clear, that is not confidence. I saw a question come up. That is not confidence, and I hate confidence. I've been working with systems for like 15 years, and every executive I ever know has wanted like one of these automated systems to have a confidence thing, and that's a really silly thing to put on these technologies, and especially this one. So yes, but it's not confidence.
Okay.
The envelope
I think this is a question for Beth. You talked about sanitizing your data. So does that mean you don't start with any of the LLMs that are available today and you start with all new data?
Correct. I mean, that's the other way to do all of AI, is to understand. So LLMs are statistically brute forcing answers through large volumes of data using large amounts of computation. And the ability to understand the meaning of the word or the ability to understand requires context to understand against. Understanding is a labor, not an act. So what we do is we take high quality data like outpatient procedures or medical protocols, and we render that into a cognitive scaffolding that the AI can use to understand against. And then we use AI to enrich data, not to predict the output. So we already know the output, but we want to formulate that output to somebody who speaks Spanish or to somebody who has an 8th grade education. So it's a wonderful way to be able to take high quality information and then utilize a language model to enrich that so that you can deliver it to the human in the way they need to receive it.